Hello everyone, and this is Krishna Saram, and in this video I am going to talk about the sudoko solver problem. And here we can see the sudoko solver problem. So I have written this problem in the sublime text. I am going to explain line to line of this program in this sublime text. So the program starts from here. First we are taking digits string which has 1 to 9 numbers as a string, and next we are taking the rows which has A to I alphabets as a single string. Now columns which is the same as the digits, so we are equating the columns with the digits. Now the squares is equals to cross of rows and columns, so here we have a function named cross. Now we will check the what is cross function. So now in the cross function we are giving two strings. Yeah, so in this cross function what we are doing is, uh, for the first we are iterating for b in b, means we are here b means rows and a means the columns. Yeah, b means columns and a means rows. So b in b means all the columns like digits will be iterated, and for a in a, so all the alphabets will be iterated. So by adding those, we'll get similar terms like A1, A2, A3, B3. So there are 9 rows and 9 columns. So we'll get 81 combinations. So let me print these squares so that you can understand what the cross function is doing. Okay, sorry. Yeah, now the code is executed. And in the sublime text we can see the output here. So all the 81 combinations A1, A2, A3, A4, A5 will become. We can also check the length. So here we can see length of the squares is 81. So the squares is nothing but a list with all the combinations of rows and columns. So next what we are doing is we are making another list named unit list. In this list what we are doing is we have all the different combinations of rows and columns and sections for the given element. So here the first loop is for C in columns. As you know, columns is equals to 1 2 3 4 9. So the every time when a cross function is called, all the row values and a single cross value will be set. That means if all the row values means A to I alphabets, and first we consider C is equals to 1, we will get the combinations of A1, B1, C1, all the combinations of alphabets with ones, and later we get all the combinations of alphabets with 2. Similarly here we can see R comma columns. That means uh, single R is single character from the R is sending, so R will be first time A, and the columns will be 1 2 3 4 up to 9. So the combinations are A1, B1, I mean A1, A2, A3, and so on. So the third combination is cross of RS comma CS. Here RS is ABC and DF and GF, and CS is 1 2 3 4 5 6 and 7 8 9. So First in here, CS means first string will be iterated 1 2 3. First string with the combinations of ABC. A1, B1 and C1 will be coming, and next combination is A4, B5 and C6, and next combinations are A7, B8 and C9. So we can understand this through the matrix given in here. So here you can see this is called as one section, and here the combinations are A1, A2, A3 and B1, B2, B3 and C1, C2, C3. So as for the strings given here, A1, A2, A3 and B1, B2, B3 and C1, C2, C3, these all will come as one combination, and D1, D2, D3 and E1, E2, E3 and F1, F2, F3. So like this all the combinations of the sections are covered. So now I am printing the unit list so you can understand what happened in the unit list. So now you can see the program is executed. So this is the unit list. It is very big. Let me divide. And first thing is all the combinations with the rows and all the combinations with the columns. And here you can see the sector. And again all the combinations with the rows. Like this all the different rows and columns are and the sectors are divided. So here you can see we have 9 columns and 9 rows and 9 sectors in this matrix. Here you can see in that matrix. So we have 9 into 3 different combinations. So we have to get the 24 list. Let me check the length of the unit list so that we can confirm it is working perfectly or not. So here you can see the number 27. So our unit list is working correctly. So next thing what they have done is the dictionary. So they have constructed a dictionary named units. So here the two constraints are S and U. S is from the S in squares. As squares we know there are 81 combinations, all the A1 to I9, and unit list is nothing but all the different lists and those 27 combinations. So first we are iterating S in squares. So let us consider S is equals to first term in S squares is A1. So uh, so the first S is A1, and next we are iterating U in unit list. U in unit list means all the lists will come. If the A1 is in any of the list, here we are checking S is in U. If that S is in that list, then we are making a dictionary of S and that U. So we can get all the different combinations. Like if A1 is the key, we can get the values as the vertical column of A1 in which it contained and the horizontal row in which A contains and in the sector in which the A contains. All the three combinations of each variable can be obtained in this dictionary. So uh, so now I am printing this dictionary so that we can understand better. Yeah, now we are printing this. So here in the output you can see the dictionary. It is very long as there are so many combinations for every variable. And yeah, this is the first variable, and now you can see all the lists that are having a1 up to here, I guess. Yeah, up to here. Those three lists will be written in the as a1 as a key and a2 similarly. So here we have to get the 81 combinations as there are 81 elements. Let's check. So here we can see there are 81 key value pairs are obtained for this. Now I am commenting this print statement. Okay. So the next thing we have what we have done is PS. It is also a dictionary. So what we are doing in the PS is first we are iterating squares. Uh, we are obtaining S values like A1, A2, A3 as we know, and now we are taking the S as a key similar to the units, and here the value is set of sum of units of S comma a empty list. So what is this sum of units of S means? Um, as we know, units of S means we are giving the dictionary a key value. All the three lists of the key will be obtained here, and what we are doing a sum function with an empty list. So all the three list with this empty list combines to form a single list, and we are using a set function. What the set function will do is it will remove all the duplicates, so all the unique uh, variables can be obtained in this set. So from this set we are removing set of s. That means here we are obtaining a variable as it is also in the key. We do not have to mention that variable in its values, so we are removing that value also. For suppose we are taking a1 from the squares, a1 will be the key here, so we are removing that a1 from this values list. So we'll get all the variables that correlates with the key. For example, in this sudoko problem, if you have a number like 9 in the a1, that number will not be in the row in which that number is having, and not be in the column in the number which is having, and it should not be in the same sector in which that number is having. So we are taking that key value and all the combinations of vector in which the that number do not have to come. So this is about PS, and now I am printing the PS so we can understand it better. So the now PS is printed. Now we'll check. Here we can see key is A1, and this is this dictionary. So it will form all the corresponding elements that related to this A1, and all the elements that relating to the A1 will be in this dictionary. So these are all the different key value pairs. So for each element we have uh, 9 row elements and 9 column elements and 9 sector elements. But there are some more common elements like uh, A1 is common in the rows and columns, so we can consider them as 8, and in the rows also we can consider them as 8. So 8 plus 8 16, and these two elements and these two elements are already repeated, so these are the four elements in the sector apart from B1 C1 and A2 A3. So totally we have 16 plus 4 20 elements. So in the each dictionary we have 20 elements. Let me check. Each key value pair we have 20 elements. So pairs of A1, sorry, all the elements of A1 has to be repeated. So for checking all of these constraints, we have also written a function named test. Here what we are checking is we are checking the length of the square. It will be 81 as there are 81 elements, and length of the unit list as we have three combinations for every element. We have 3 into 9, 27 elements, and length of units. Length of units means here we are also iterating loop. That means in each square key value we have three lists, so the length of each list will be 3, and in the value pairs we have 20 elements in each set, so we are getting 20. And in the units, uh, the variables will be like this, like C2 means if you are considering the key as a C2, all the elements different lists in the C2 are these lists. So the PS of C2 means all the combined elements as a set, so these are all the elements. So if all the conditions are true, it will print all tests are passed. So we will call this function and check it is working for all the test cases or not. So now here you can see the message all tests are passed. So we can say that all tests are passed. So this is about the first part of the sudoko solving problem. We'll see another part in another video.